Hello everyone, this is Maíra Bezerra again from Conservation International. Good to be with you. We have reached the final subsession on the topic of freshwater ecosystem services. In the previous lectures, we learned about the production and sustainability of freshwater ecosystem services. We also touched on some quantification methods as well as how to use the Freshwater Health Index to assess these services. In the next two videos, we will continue to learn how the FHI can be useful when assessing freshwater ecosystem services. More specifically for this lesson, we will evaluate water trade-offs with the Freshwater Health Index. As we all know at this point, fresh water is often limited and numerous needs exist within a basin. Water of sufficient quality must be allocated to different users, including municipal human consumption, agriculture, industry, energy, environmental flows, and so on and so forth. Water needs to be allocated in a manner that achieves economic, social, and environmental goals at the same time. Water allocation, therefore, makes trade-offs between the priorities of stakeholders, reliability of water supply, equity, economic growth, and maintenance of ecosystems. Water allocation can change for a variety of economic, social, and environmental reasons. These reasons include, for instance, greater need for municipal water due to population growth, industrial or agricultural expansion, droughts, as well as water diversion or transfer projects to deliver water into or out from a basin. We will use the application of the Freshwater Health Index in the Lower Mekong as an example of analysis of trade-offs with the FHI. The Lower Mekong is a transboundary basin as it drains areas from three countries, Laos, Cambodia, and Vietnam. This basin is still one of the richest natural areas in terms of biodiversity, but of course is facing serious pressure from economic development in what is the poorest part of Southeast Asia. Recognizing that in each context, end users are likely to have different priorities for maintaining a healthy basin, and that within a basin, different stakeholder groups will have different priorities, we wanted to explore these differences and reflect them quantitatively through the indicators of the FHI. For this, we will take a look at the indicator of flow connectivity of the FHI. If you recall from the lecture on ecosystem vitality, this is an indicator that measures the longitudinal connectivity of the river network for fish species. With dam constructions along streams and rivers for the purpose of producing electricity or storing water, there is always a conflict between the production of these services and the structure and functioning of the freshwater ecosystems. For example, the preservation of biodiversity. In the case of aquatic biodiversity, the conflict occurs because dams are barriers for the free migration of fish from up to downstream and vice versa. Therefore, dams commonly influence fish behavior, such as reproduction, which in turn can reduce fish abundance and diversity. Remember the examples of the Dourado and Tambaqui fishes in the Amazon basin given in the lecture on basin condition of the ecosystem vitality session. In this example, basin managers should understand the extent of the impact of dam construction on fish biodiversity to be able to make informed decisions about the trade-offs between constructing the dam and the potential biodiversity loss. To help managers understand such trade-offs, they can use analysis of scenario for this. The aim of scenario analysis using the Freshwater Health Index approach is to enable stakeholders to consider the changes encompassing multiple dimensions of aquatic ecosystems and several ecosystem services. Instead of focusing on defining a definitive outcome on the state of the system in response to future changes and development, the process intends to help stakeholders identify potential trade-offs they are likely to face while managing the freshwater system and assess what steps they might carry out to mitigate risk to the overall health of the system. For example, this picture shows the existing dams in the lower Mekong and the current impact on flow connectivity. Dams are concentrated in the upper portion of the basin. Therefore, streams and rivers are still fairly connected. The FHI score under this current condition is 56. Remember that we are using a scale from 0 to 100, where 100 means excellent health. If the dams that are planned for the lower season are included, the flow connectivity score decreases about half. And you can see the impact on the connection of streams in this scenario. If we then add the dams under development, the score decreases a little bit more to 26. When those dams planned for the Sekong are included in the analysis, the score reduces even more, goes to 18, achieving a very critical value as nearly all stream network is disconnected at this point. Finally, with the development of all dams that are planned, you can see that nearly all streams are disconnected, and the clear implication of what this disconnection would mean for fish biodiversity. So here are some key take-home messages from the lecture that we just had. We know that there are multiple competing interests and users in a basin. Therefore, trade-offs are unavoidable when managing freshwater for multiple uses. Analysis of scenario can help to assess losses and gains, and the Freshwater Health Index provides one of the platforms to assess impacts of different scenarios on water ecosystem services. And this is the end of this lecture. We will talk again on our next video on stakeholder engagement with the Freshwater Health Index for the purpose of assessing freshwater ecosystem services.